Motion in one dimension. Now when we talk about motion in one dimension, what does it mean? One dimension. Only one dimension is changing. So when a body moves along a straight line, its motion is said to be one-dimensional motion. So when a body moves along a straight line, when it moves along a straight line path, then the motion is said to be one-dimensional motion. It is also known as rectilinear motion. Another name given to it is rectilinear motion. So another name given to it is rectilinear motion. Now, say, let us take an example. A boy is standing over here. He is walking along the straight road. At t equal to 0, x is 0. At t equal to 1 second, the boy comes over here. Say x equal to 2 meter. At t equal to 2 seconds, say the x is 4 meter. So with time, x coordinate is changing. This is one-dimensional motion. Or you can take another example. Say, you have a mosquito sitting on the floor. At t equal to 0, it is on the floor. Now it starts going up. It starts going up. Say if we call this as z, z coordinate is changing. At t equal to 1, say z is the distance from the ground. The mosquito comes over here. So z is 4 meter. Then the mosquito goes over here at t equal to 2 seconds. Z is 6 meter. So it's going up. So only one coordinate is changing. When one coordinate is changing, automatically it moves along a straight line path, and that is motion in one dimension. Now, to start with the very basics of motion in one dimension, you have to have a clear idea of what is distance, what is displacement, what is speed, what is velocity, what is acceleration. Now, what is distance and what is displacement? This you have learned when you all were small. Just a revision. What is distance? What is displacement? Say a car moves 3 kilometers in this direction and 4 kilometers in this direction. The distance covered is the actual length of path covered. Distance is the actual length of path covered. It is the actual path covered. It is the actual length of path traversed. So what is the distance over here? It is 3 plus 4. So the distance covered is 3 kilometers. Let me tell this as give me the same unit. This is also kilometer. So it is 3 kilometers plus 4 kilometers. Distance is 4 plus 3, 7 kilometers. But in this case, what is my displacement? The car was moving 3 kilometers and then 4 kilometers in this direction. Displacement, as you have learned when you were small, it is the shortest distance between the initial and the final position. So here, this is my initial position. This is my final position. And the shortest distance between the initial and the final position is this length. This is my displacement. It is the shortest distance between the initial and the final position. By Pythagoras theorem, this will come to be 5 kilometers. Now, when is this displacement needed, children? Say for example, you have two students. Say you have Abhijit and say you have Spandan. Now, Abhijit grows up, gets a very good job, buys a brand new car, and that car gets stolen. Abhijit's friend Spandan at that time becomes the inspector in charge of Kolkata. Now Abhijit rings up Spandan and requests Spandan to find his car. Now Spandan is Abhijit's friend. He will do whatever he can to help him. So he uses his resources, finds his car. Very happily, Spandan rings up Abhijit and tells him, Abhijit, your car is found 50 kilometers from your house. Now both of them are very happy. Spandan is happy because he has found Abhijit's car. Abhijit is very happy because he found his own car. Happily, Abhijit goes out of the house to get his car. Now, once he gets out of his house, the first question which comes to his mind, 50 kilometers, in which direction to go? In which direction should I go? East, west, north, south? So Spandan should have told Abhijit 50 kilometers in which direction. So at times direction becomes very, very important in physics. And those quantities which find very importance in direction in physics, those are called vector quantities. Those are called vector quantities. Here, displacement is a vector quantity. Without direction, displacement is incomplete, just like Spandan's message to Abhijit. 50 kilometers from your house made no sense. He should have told him 50 kilometers northeast, 50 kilometers east. So, displacement is a vector quantity whose direction is very, very important. So, displacement is a vector, while distance is a scalar quantity. It does not need any direction. Now, I told you for the basic concept, you have to know what is distance, displacement, what is speed, what is velocity. Now, speed, as you have learned when you all were small, speed is nothing but distance by time. Now, children, distance is a scalar quantity. Time is a scalar quantity. Scalar divided by scalar is a scalar quantity. Now what you're going to remember, scalar into scalar will give a scalar quantity. Scalar by scalar will give a scalar quantity. Vector into scalar will give a vector quantity. Vector into vector may give a scalar or a vector quantity. Vector into vector may be a scalar, may be a vector. Now here we are getting scalar by scalar. Vector by scalar will give a vector, children. Vector by scalar will give a vector. Here is a case of scalar being multiplied with scalar, so speed is a scalar quantity. Distance has the unit, say meter times second, so mk's unit speed can be meter per second. Then speed, you might come across certain terms like in speed, you might come across certain terms like, number one, what is uniform speed? Now when you talk about uniform speed, see a body moves 2 kilometers in 1 hour, again 2 kilometers in 1 hour. This is uniform speed. He might change the direction also. Say he moves 2 kilometers in 1 hour, then changes the direction, moves 2 kilometers in 1 hour. This is also uniform speed. In uniform speed, direction is not at all important because it is a scalar quantity. So, direction is not important in speed. Next, you might come across another term, non-uniform speed. In non-uniform speed, what you have? Say a body moves 2 kilometers in 1 hour, and then 4 kilometers in the next hour. This is non-uniform speed. Next, you might come across another term, average speed. Average speed is total distance. divided by total time. It is total distance by total time. Very often you might come across another term which is called instantaneous speed. Instantaneous speed. This means speed is changing every moment. Now this can be calculated with the help of calculus, which you will be learning in class 11. Instantaneous speed is a speed which changes every instant, which can only be calculated with the help of calculus. So while you go through the chapter, as we go through the chapter, we might come across uniform speed. You might come across non-uniform speed, average speed, which is total distance by total time, and instantaneous speed, which changes every moment. Now, we move to what is velocity. Velocity is nothing but displacement divided by time. Now, children, displacement is a vector quantity. Remember the Spondon and Abhijit? Direction was important. Time is scalar. Vector by scalar is a vector. So velocity is a vector quantity. Here the direction becomes important. Like speed, while studying with velocity again, you might come across the four terms. One is, what is uniform velocity? You might come across non-uniform velocity, average velocity, and instantaneous velocity. Now, as direction is very important here, so when we talk about velocity, for uniform velocity you cannot change the direction. If you are moving 2 kilometers in 1 hour, then you cannot change the direction. It is 2 kilometers in 1 hour again. But if you change the direction, it now becomes non-uniform velocity. 2 kilometers in 1 hour, and then I move 2 kilometers in this direction as 1 hour. This is non-uniform velocity. It might be uniform speed. It is uniform speed, but non-uniform velocity. Or it can be like this. Here you move 2 kilometers in 1 hour, and then you move 4 kilometers in 1 hour. This is non-uniform speed as well as non-uniform velocity. average velocity is total displacement divided by total time. Total displacement by total time. Instantaneous velocity again is changing every moment, and this can be calculated with the help of calculus. So basic idea of uniform velocity, non-uniform velocity, average velocity is needed here. Velocity is a vector quantity. Say for example, if we take an example, say you have a body moving in a circle. In circular motion, speed is tangential. Now what is tangential? See, this is radius. Tangent is perpendicular to the radius. Okay, tangent is perpendicular to the radius. This is 90 degree. Now see, it is 2 meters per second. When the body is moving in a circle, when the body comes over here, this is my radius. Speed is 2 meters per second, but the direction has changed. When the particle comes over here, this is radius. This is 2 meters per second. The direction is changing. So this is an example of uniform speed, but non-uniform velocity. Why is it non-uniform velocity? Because it is non-uniform velocity because the direction changes. As the direction changes, velocity changes. As the direction changes, velocity changes. So we call it non-uniform velocity. Circular motion is an example of, provided it is having the same speed, of course, it is uniform speed but non-uniform velocity because the direction of the velocity changes point to point. So velocity has two things. It has magnitude and at the same time it has direction. Another basic term which we will be needing is acceleration. We will be needing this term acceleration. The acceleration small a is change in velocity. It is change in velocity divided by time. It is change in velocity divided by time. Now, this is vector and time is scalar. So vector by scalar is vector. Vector by scalar is vector. Acceleration is change in velocity divided by time. What is the unit of change in velocity? Velocity has the unit of meter per second. Children, m by s, we will write it as ms to the power minus 1. And time is in seconds divided by second. So when second goes up, the unit of acceleration becomes meter s to the power minus 2. So acceleration is actually change in velocity by time. When the speed of the body decreases, we say there is retardation. When the speed of the body decreases, we say there is retardation. So remember, negative acceleration is known as retardation. Now these are the basic concepts which we will be needing, and this you have done before also. Let's do one or two basic sums, and then we'll move on to graphical representation. Let me take a sum. Say the speed of a car is 72 km per hour. Express it in meter per second. Express it in meter per second. Now this is 72 km per hour. Now you have to convert it into meter per second. This is 1000. 1 hour is 3600 seconds. Kilometer to meter, children, you have to multiply with 1000, and 1 hour is 3600 seconds. Now, for easy calculation, children, see this 1000 by 3600, this 20 cancels, 2 5s are 10, 18. So you can make it 72 into 5 by 18 meter per second. So when you want to convert kilometer per hour to meter per second, you can simply multiply with 5 by 18. So this is 18 4, isn't it? 18 4 72, 4 5s are 20. So it is 20 meter per second. Now these are very childish sums which you have done in class 7. This is just a revision, just a warm-up class before we enter into motion in one dimension. Now motion in one dimension, it needs vigorous practice. Next day while we will be doing the sums, until and unless you have basic concepts, it will be difficult. Now, say we take another sum. A car travels 30 kilometer. A car travels 30 kilometer with a uniform speed of 60 kilometer per hour. And then the next 30 kilometer with a uniform speed of 40 kilometer per hour. Find the average speed of the car. Find the average speed of the car. Now, as per the sum, the car travels the first 30 kilometers with a speed of 60 kilometer per hour, and then the next 30 kilometers with a speed of 40 kilometer per hour. We have to calculate the average speed. Now, average speed, the definition is average speed. The definition is total distance divided by total time. Now, total distance we know it is 30 plus 30. So, total distance is 30 plus 30. But we don't know the total time. We have to calculate the time. Now, in this part, how do we get the time? Time t1 is distance by speed. Time is distance divided by speed, because speed is distance by time. Say speed s is distance by time. So time is distance by speed. So this 0 cancels. It is half hour. Now for this one, how do we get the time t2? It is distance by speed. Distance is 30. Speed is 40. So it is 3 by 4 hour. So what is my total time? My total time is half hour plus 3 by 4 hour. You are going to add this 2. Total time is this half hour and this 3 by 4 hour. So 4 is the LCM. 2 plus 3, 5 by 4 hour. So total time is 5 by 4 hour. So this becomes 60 divided by 5 by 4. So 2s are 8, 48. See, this is unit is kilometer and this is 5 by 4 hour. See, the unit was hour. So it will be 48 kilometer per hour. We were asked to find the average speed. Average speed is total distance by total time. Total distance was 30 plus 30, 60. And total time we found out. For the first time it is half hour. For the second part the time is 3 by 4 hour. So we added the two time. Half hour plus 3 by 4 hour. It is 5 by 4 hour. And then we have substituted here in the total time. Our average speed is 48 kilometer per hour. Now let us take another sum. Say a train takes 2 hours to reach station B from station A. This is station A. And this is station B. A train takes 2 hours to go from station A to station B. The time taken is 2 hours. And then it comes back from B to A in 3 hours. It comes back in 3 hours. Distance from station A to station B is 200 kilometers. Here we have to find out number 1, the average speed. And number 2, the average velocity. Now what is average speed? Average speed is total distance covered divided by total time. What is average velocity? Total displacement divided by total time. Now what is my total distance? The train takes 2 hours to go from A to B. The distance covered is 200 kilometers while going, and while coming back it has to cover 200 kilometers. So my total distance will be 200 kilometers plus 200 kilometers. 200 kilometers while going from A to B, and 200 kilometers coming back from B to A. total time is 2 hours while going, 3 hours while coming back. So it is 2 hours plus 3 hours. So my average speed becomes 400 kilometer divided by 5 hours. So it is 80 kilometer per hour. Now we come to average velocity. Average velocity is total displacement by total time. Now what is displacement? It is the shortest distance between the starting and the final point. It is the shortest distance between initial and final position. Now the car goes from station A to B. The car goes from station A to station B. It goes from station A to station B and then comes back from B to A. It comes back. So this is my starting point, starting and final position. Starting and final position. So the shortest distance between starting and final position is 0. Total time is 2 plus 3, 5 hours. But the starting and the final position is the same point. So my total displacement is 0. So in this case, my average velocity is 0. Now let us take another sum. Say we take another sum. A bicycle initially moving with a velocity of, say this is a cycle, okay, I'm not very good in drawing, but so this is a cycle. Let me write this as a cycle better. Let me write it as a cycle. You have a bicycle initially moving with a speed of 5 meters per second. Initial velocity, children, we will denote with the small letter u. Now it accelerates. My acceleration is given as 2 meters per second square. It accelerates for 5 seconds. It accelerates for 5 seconds. Now you are asked to find out the final velocity. Now acceleration, as I told you, acceleration is change in velocity divided by time. So it is final velocity v minus initial velocity u divided by time. This is acceleration. Now what is my acceleration? Acceleration given is 2. So put the value of acceleration over here. Acceleration is 2. Final velocity we have to find out. Initial velocity is 5. So put the value of initial velocity over here. Time is 5 seconds. So put the value of time as 5. Now you have to solve. Just cross multiply. 5 into 2 is 10, is v minus 5. So final velocity becomes 10 plus 5. That is 15 meter per second. 15 meter per second. So this is the very basics, children. If I go back to the very beginning of the class, we were doing motion in one dimension, which we said that only one coordinate will change with time, either x or y or z. It is only one coordinate will change. Next we understood what is distance and what is displacement. Distance is the actual length of path covered. It is a scalar quantity. And what is vector? It is the shortest distance between the initial and the final position, and it is a vector quantity. Then we went to what is speed. Speed is distance by time, and I said scalar into scalar will give scalar, scalar by scalar is scalar, vector into scalar is vector, vector into vector may give a scalar quantity or a vector quantity, vector by scalar is vector. Here distance was scalar, time was scalar, so speed was scalar. Distance had the unit meter, time second, so the unit of speed was meter per second. I told you while doing the chapter you might come across uniform speed, non-uniform speed, average speed, instantaneous speed. Instantaneous speed we do not need now. You will be doing it in class 11 with the help of calculus. In speed, as speed is a scalar quantity, direction is not important. So even if you move 2 km in 1 hour and change the direction, that will come under uniform speed. Next we went on to velocity is displacement by time. Displacement was vector, time was scalar. So vector by scalar we know is vector. So velocity was vector. It had two things, magnitude as well as direction. Now while doing the chapter you might come across uniform velocity, non-uniform velocity, average velocity and instantaneous velocity. Uniform velocity is only 2 km per hour. This diagram is important. If you change the direction, then it comes under non-uniform velocity. In velocity, direction is very, very important. Average velocity is total displacement by total time. Then we went to what is acceleration. It is change in velocity by time. Change in velocity is vector, time is scalar. So vector by scalar is vector, so acceleration is a vector quantity. Negative acceleration is retardation. Unit of acceleration is meter per second square. Then we learned how to convert kilometer per hour to meter per second. Simple numericals on average speed, average velocity and acceleration. So next day we are going to do some basic sums on this and then move on to graphical representation of the chapter, where through the graphs we have to calculate speed, velocity and acceleration.